Welcome to my YouTube channel. I am Shlok Kulkarni and today we are going to do our next quiz for the month of January. This is quiz number 7 and it will consist of questions from meteorology, navigation, technical, regulations, radio telephony, etc. etc. So let's start with today's question number 1. The datum setting knob in altimeter varies its datum ranging from what level? Sea level, ground level, flight level, all of the above. So over here they are talking about the datum setting knob. The datum setting knob. Now the datum setting knob in altimeter is this. We call it Coulson window also, or also known as altimeter pressure setting knob. Altimeter pressure setting knob, or Coulson window, or datum setting knob. Now, this varies its datum ranging from, in this altimeter setting window, you have the provision to put, your QNH, which is your mean sea level pressure. You can put QFE, which is your aerodrome level pressure. You can put standard pressure setting, which is your ISA pressure of 1013 decimal 25 millibars, right? So you can put this three kinds of pressure in your altimeter pressure setting window, and depending on the pressure setting that you put, if you put QNH, your vertical distance, the altimeter will give you vertical distance starting from mean sea level. Okay, QNH is mean sea level pressure, that is aerodrome level pressure reduced to mean sea level. So when you put QNH, or local atmospheric pressure, in the altimeter setting window, you will be given a vertical distance which will be starting from mean sea level, meaning from the datum, the mean sea level will be your datum, and from that the vertical distance will be measured. If you put QFE in the altimeter setting window, your vertical distance will start from ground surface ground surface. Okay, that is your QFE, aerodrome level pressure. So if you put QFE pressure setting in the window, the vertical distance will be beginning from the ground. It can be your aerodrome level, a ground level below you. So that vertical distance is called height. In case of QNH, the vertical distance is called altitude. When you put standard pressure setting in the altimeter setting window, the vertical distance will be measured from 1013 datum, Okay, so that will be your beginning point or origin, that datum of 1013 pressure level, and beginning from that the vertical distance will be measured. Now the vertical distance corresponding to standard pressure setting is called flight level or pressure altitude. So based on this data, the datum setting knob, it can vary its datum. So ranging from sea level, which is your QNH, ground level QFE, flight level 1013. So all three options are correct. So that's why the correct option is option delta, which is all of the above. Depending on the pressure setting that you put in the window, your vertical distance will be proportionate to that. Is the altimeter flag completely visible? So this is your altimeter flag, this zebra crossing, white black lines. This is called altimeter flag. So when is this altimeter flag completely visible? Okay, so the answer is at sea level. When you fly away from sea level and climb to higher and higher altitude, this flag, the size of this flag goes on diminishing. That means this flag will start disappearing slowly and slowly. At 10,000 feet and above, this flag will get completely disappeared. Okay, it will not be visible to you. It will completely disappear from the instrument. Okay, so the answer is completely visible at sea level, completely invisible at higher altitudes 10,000, beyond 10,000 feet, completely invisible. Next, which instrument will give erroneous reading, means wrong readings, by impact side of pitot tube getting blocked? So here, this is your pitot tube, okay? And the job of pitot tube is to supply or provide pitot pressure, a combination of static and dynamic pressure, to the airspeed indicator. Now, if the impact side, this is the impact side of the pitot tube gets blocked. It gets blocked. If it gets blocked due to some ice or any dirt particles or any insect of that size, what will be the consequence of that? So, which instrument will get affected? So, pitot tube, the only pressure instrument which works on pitot pressure and hence dependent on pitot tube for that is your airspeed indicator. Is your airspeed indicator. Whereas vertical speed indicator and altimeter are also pressure instruments, but they work on static pressure only. They work on static pressure only. Whereas your ASI works on both static pressure and your dynamic pressure, which is your pitot pressure. Okay, so option D can be eliminated because turn and slip indicator isn't a pressure instrument, it's a gyroscopic instrument. So that is wrong. Question 4. Pilots are required to have the anti-collision light system operating at what times? Now, these anti-collision light systems are meant for aviation safety. So you have to switch on these lights whenever you are starting your engines or before starting the engines to alert all ground personnel around aircraft that you are about to begin your engines. So anti-collision lights can be in two forms. It can be the beacon lights, which are red in color on the tail section, vertical stabilizer on the corner of vertical stabilizer. Also on the top of the fuselage and the bottom of fuselage, there are these red anti-collision lights which are flashing. And the second anti-collision lights is your strobe lights. Strobe lights are located on both the wingtips and they are flashing white lights. So these are two anti-collision lights. And option A says during all types of operations, day and night, anytime the pilot is in the cockpit, anytime an engine is in operation. So anti-collision lights must be activated during all types of operations, whether it's daytime or nighttime. Question 5. How can you determine if another aircraft is on a collision course with your aircraft? Okay, so how can you determine or come to know that there is another traffic which is in a collision course with your course? That means if continue, if your aircraft and the traffic continues on its course, sooner or later you both will be colliding with each other. So this is called collision course. So how to determine that? Now let's say I will take a new slide. This is your aircraft moving the left direction, okay? And there is another aircraft right in front of you but moving in the opposite direction. That means it is moving towards you. Such a thing happens that there is a traffic which is at same altitude or same flight level as yours and is directly approaching you from the front Okay, we call this head on. We call this head on. Okay. Now, if this is the case where the other traffic is approaching you head on, so the other traffic will be visible to you through the windscreen. But as your aircraft and the traffic come closer and closer to each other, the size of the traffic, this size of the traffic which will be visible to you through the windows or the windscreen will grow in size slowly and slowly. It is very difficult to determine the speed at which the traffic is approaching you. The only clue that you have will be that the size of that traffic will increase or grow in size as it comes near you. So this is one option. So that is one possibility in which two aircraft can come very close to each other and collide with each other. The second option is there is a point here. Your aircraft is approaching that point from this direction. Okay, and there is another aircraft which is approaching the same point but from another direction. Let's say from this direction. Okay, so in this way also you can determine that your aircraft and the traffic, okay, the other traffic is on a collision course. How? If you are approaching this point and there is other traffic to your right hand side approaching the same point, you will be able to see the red navigation light of that traffic. The red navigation light of that traffic. If you are approaching this particular point and there is another aircraft which is approaching the same point but from your left hand side, in that case, the green navigation light of that aircraft will be visible to you. Okay, green navigation light of that aircraft will be visible to you. And in this case, in head-on collision, what lights will be visible to you? Green light and the red navigation light. Okay, so if you see that there is another traffic in front of you whose relative position respect to you is not changing. Okay, that means that other traffic is neither climbing nor descending. It is on the same flight level or altitude as yours. And you will see that the size of that aircraft as it approaches you goes on increasing. So these are the ways in which you can determine that you are on a collision course with another traffic. Apart from that, you also have to maintain a listening watch on RT to check whether there is any possibility of other traffic in the vicinity of your aircraft. Uh, uh, Flying very close to you or crossing your flight level very close to you or making any movements which you think are unsafe for your aircraft or for any other aircraft. So maintaining a constant listening watch on radio telecommunication equipment is must. So the nose of each aircraft is pointed at the same point in space. So this is the case. The nose of each aircraft is pointed at the same point in the space, in the airspace. So that means this is a hot spot, meaning there can be a collision course or a possibility of collision in such a scenario. And this happens frequently when two aircraft are approaching or converging at the VOR station. Let's say this is a VOR station or VOR ground station. Okay, from every VOR ground station there will be radials emerging from it. Okay, and if there are two aircraft which are following two different radials of a VOR inbound, okay, so at same altitude, okay, same distance from the VOR, so it is a possibility that both will converge towards the VOR at the same time. So you have to be careful that time. Next, the other aircraft will always appear to get larger and closer at a rapid rate. There will be no apparent relative motion between your aircraft and the other aircraft. So there will be no apparent relative motion between your aircraft. Now option B will be the incorrect option because here it states rapid rate. Now when there is another aircraft which is approaching you head on, Okay, your eyes cannot detect how fast that aircraft is moving towards you or how slow it is moving towards you. So option B can be eliminated. The nose of each aircraft is pointed at the same point in space, and the C option, there will be no apparent relative motion between your aircraft and the other aircraft. So the correct option will be option number A. So this is the answer. So remember this point: head-on collision and convergence at the same point. Previous question was the second last question before this about beacon. So this is how beacon looks on the tail of the aircraft, on the top of the tail of the aircraft, red in color. And then we have strobe lights, which are located on the wing tips, which are white in color. So both are anti-collision lights. Also, you have anti-collision lights on the top and bottom of the fuselage. Next question. Hail is most likely to be associated with what kind of cloud? Now, hails are very solid, rock like a small stone-like ice particles. Okay, and they are a result of very unstable weather and very dangerous turbulent clouds. And those clouds are cumulonimbus clouds. Option B is the correct option. Okay, so cumulonimbus clouds produce the most dangerous hazards to aviation safety: lightning, hailstorm, intense icing, turbulence. So this is one of the consequences of a cumulonimbus cloud. Cumulus cloud, on the other hand, is a thunderstorm in the incipient stage. Okay, in the incipient stage is the starting stage. The starting stage of a thunderstorm is a cumulus cloud. A thunderstorm always develops or originates from a cumulus clouds, then it grows in size and later on becomes a cumulonimbus clouds in its mature stage. So the hailstorm, you get hailstorm or hails are formed when cumulonimbus cloud is in its mature state. Okay, when there is both updrafts and downdrafts. The availability of both these updrafts and downdrafts aid in the formation of hails. So cumulus cloud can be eliminated, and along with that, stratocumulus cloud can also be eliminated. It's irrelevant. So option B is the correct option. 7. The most severe weather conditions like destructive winds, heavy hail, and tornadoes are generally associated with what? So is it associated with slow moving warm fronts which slopes above the tropopause, squalls, fast moving occluded fronts? So option A can be eliminated because warm fronts never expand or extend above the tropopause in the first place. And second point is that warm fronts are generally associated with moderate or less harmful weather conditions like fog, rain, like that. Okay, so warm fronts are not associated with destructive weather phenomena. They are generally associated with moderate weather phenomena. And second point, like I said, the tropopause. They never extend above the tropopause. So option A can be eliminated. Option C can also be eliminated because there is no such thing as fast moving occluded fronts. We have occluded fronts labeled cold occluded front or warm front occluded front, but we don't have occluded fronts on the basis of their speeds, like fast moving occluded front, slow moving occluded front, like that. So option C is also wrong. We are left with option Bravo, which is squall lines. Now what are squall lines? Ahead of a cold front. Okay, if this is your cold front, ahead of a cold front, there is always a huge band of cumulonimbus clouds, a huge band of cumulonimbus clouds like for 100 nautical miles, 200 nautical miles. So before a cold front arrives at a point, they will be first preceded by a squall line. Squall lines are nothing but a big or a large band of cumulonimbus clouds. Okay, and this cumulonimbus clouds will, as you all know, are associated with unstable weather and hence fast, furious winds, hailstorms, lightning, tornadoes, etc. etc. Apart from that, cold fronts, as opposed to warm fronts, are also associated with bad weather. Okay, bad or worse weather, worse than warm fronts. So option B will be the correct. Question 8. If an aeroplane is consuming 12.5 gallons of fuel every hour at altitude 8,500 feet, the ground speed is 145 knots, how much fuel is required to travel 435 nautical miles? Now distance is 435 nautical miles. Speed is 145 knots. The time. The time that you will need to cover this distance at so and so speed will be distance divided by speed, which is 435 divided by 145 equal to, so time will be 3 hours, will be 3 hours. Now fuel consumption rate is 12.5 gallons every hour per hour. So for 3 hours it will be how much? So cross multiply, x will be equal to 3 into 12.5, which is equal to 37.5 gallons. So to travel a distance of 435 nautical miles for 3 hours, you need 37.5 gallons of fuel. So the closest option is option C, 38 gallons. 38 gallons. With this, we come to the end of this lecture. I hope you have understood all these 8 questions and the concept behind each and every one of them. Keep practicing these random questions so as to be confident and become and train your mind for your next exams like ATPL exams, airline exams. The most important is airline exams, where you tend to get a mix of questions from Met, NAV, Rex, technical, radio, telephony. So all the best. Keep learning.